What if there was a universe where you made different decisions and your life was completely transformed? This idea, seen in films such as Doctor Strange, in the Multiverse of Madness, and explored in depth by contemporary science, brings to light one of humanity's most intriguing questions. Do we live in just one reality? Or are there infinite versions of ourselves in other worlds? The concept of the multiverse is not just a science fiction gimmick. It is explored by some of the most brilliant minds in modern physics, such as Stephen Hawking and Brian Greene. According to theories such as string theory, quantum mechanics, and cosmic inflation, it is possible that our universe is just one, among infinite others, each with its own laws, possibilities, and alternative versions of reality. But what exactly is the multiverse? How does it work? What would it be like to live in a parallel universe? And, more importantly, will we ever be able to prove its existence? Today, we'll explore this fascinating journey, connecting science, philosophy, and pop culture to try to answer one of the biggest questions of all time. Are we alone in existence, or are we part of something much bigger than we imagine? The idea of the multiverse is both exciting and disconcerting. It makes us question everything we know about reality. Who are we? Why are we here? Do our choices have weight, or is there an alternative universe for every decision we failed to make? These questions are not just hypothetical. They are at the heart of one of the most complex and daring scientific discussions of our time. The notion that we live in a multiverse, a set of parallel universes coexisting with our own, did not just arise from the imagination of science fiction screenwriters. It is deeply rooted in legitimate scientific theories, such as quantum mechanics, cosmology, and string theory. To make the mystery even more intriguing, there are several types of multiverse suggested by scientists and philosophers. Cosmologist Max Tegmark, for example, classifies the multiverse into 4 main levels. Level 1 multiverse. Universes with different initial configurations, but governed by the same laws of physics. Imagine this as remixed versions of our universe. Level 2 multiverse. Universes with completely different physical laws. Some of these realities might not even allow for stars or life. Level 3 multiverse. The quantum multiverse, where each decision or event creates multiple parallel realities that coexist in a quantum cloud. Level 4 multiverse. A speculative level, where each universe follows different logic and mathematics. In addition to physics as we know it, each of these approaches raises more questions than it answers. At the simplest level, the multiverse suggests that there may be other universes very similar to ours, but where things happened in slightly different ways. On another level, it implies realities so strange that our brains could not even comprehend them. Multiverse in pop culture. The fusion of philosophical and scientific ideas perhaps. It is in pop culture where multiverse concepts really come to life and become accessible to the general public. Films, series, and books make us imagine what it would be like to live in alternative realities, often bringing us face to face with different versions of ourselves, or with choices we never made. The Marvel Cinematic Universe, MCU for example, brought the concept to the mainstream with stories like Doctor Strange in the Multiverse of Madness and Loki, where the fight between variants of the same character reveals how seemingly small decisions can generate drastically different realities. Another example is Rick and Morty, which mixes absurd humor with the idea of infinite universes in which all possible scenarios, no matter how bizarre, can actually exist. Additionally, films like Everything Everywhere All at Once have challenged the boundaries of fiction by exploring how our lives can be shaped by the choices we make or don't make. And, of course, there is the iconic Matrix, which questions the very notion of reality as something fixed and unchanging. These narratives not only entertain, but also help us understand the deep philosophical and emotional implications of the multiverse. They force us to grapple with disturbing questions. What if you could change all your choices? Would the new version of you still be you? While pop culture puts the multiverse in the spotlight of imagination, science tries to decipher it with real tools and complex theories. Let's talk about some of the main approaches that support the scientific idea. After the Big Bang, our universe underwent an extremely rapid expansion. The theory suggests that this expansion was not uniform, creating bubbles of independent universes, each with unique characteristics. Our cosmos would be just one of these bubbles. In the microscopic world of subatomic particles, events are not determined, but probabilistic. Each time a quantum choice is made, a parallel universe is created to accommodate all possibilities. This is the famous multiverse of many stories. String theory, one of the most promising theories in physics. It suggests that the universe has more dimensions than we perceive, perhaps as many as 11 dimensions. This paves the way for universes with completely different realities, coexisting alongside ours. These ideas, while fascinating, come with challenges. How can we prove something that is beyond direct observation? And how do we reconcile these concepts with our philosophical notions of time, free will, and identity? If there really are other universes, how would we deal with this idea? This discovery would question fundamental notions of philosophy, religion, and our perception of ourselves. Does the fact that there are infinite versions of you diminish the importance of your choices? Or does this give even more value to the uniqueness of your life, here and now? The multiverse also challenges traditional religious beliefs. If there are infinite universes, would God be responsible for them all? Is there a greater purpose behind this infinite diversity? Even outside the religious realm, the multiverse can make us uncomfortable or perhaps even liberate us. It reminds us of how vast and unknown the cosmos is, while also connecting us to the idea that we are part of something much bigger than we imagine. The idea of multiple realities is not new. Long before contemporary scientists like Stephen Hawking put forward hypotheses about the multiverse, thinkers of the past were already speculating about worlds beyond our own. The multiverse, as a concept, was born at the intersection of philosophy, spirituality, and science, growing as our understanding of the cosmos evolved. The multiverse may have its first expressions in ancient Greek philosophy. Pre-Socratic philosophers, such as Anaximander, 610-546 BC, speculated about the existence of infinite worlds, being born and dying in eternal cycles. For these thinkers, the universe was not fixed, but dynamic, filled with continuous possibilities. Another Greek philosopher, Democritus, known for defending the atomic theory of the universe, also suggested that atoms could form infinite worlds, each different from the other, governed by its own conditions. Epicurus later expanded on this idea, suggesting that the infinite vastness of space could contain multiple cosmoses. Although these ideas were impressive for the time, they were heavily rooted in speculative thinking without the scientific basis we use today to debate the multiverse. But the seed was planted. The dream that our reality was not the only one began to take shape. Spirituality has also flirted with the concept of parallel realities, or multiple planes of existence. Many religious traditions, especially Eastern ones, suggest that there are dimensions beyond our own. Buddhism, for example, speaks of multiple realms of existence, such as the plane of the gods, the plane of humans, and the plane of spirits, each with their own laws and characteristics. In Hinduism, the idea of cyclical universes is intertwined with the concept of kalpas, infinite periods of creation and destruction. In Christianity, although less explicit, theology frequently discusses the possibility of different planes of reality, such as heaven, hell, and earth, separated by spiritual barriers. These visions, very different in their approaches, connect to the human desire to understand what exists beyond what we perceive. They laid the cultural foundations for the later development of what would become the modern multiverse. In the 16th century, Italian philosopher and theologian Giordano Bruno took a bold step by combining philosophy and science. He challenged the geocentric view of the universe, the idea that the Earth was the center, by stating that the cosmos was infinite and that there could be other solar systems like ours, with inhabited planets. Bruno's views were radical, even heretical in his time, and he was eventually sentenced to death by the Inquisition. But his idea of an infinite universe with infinite worlds contributed powerfully to multiverse thinking in the future. While philosophy and religion speculated about multiple worlds, it was in the 20th century that the concept began to take concrete scientific forms. The turning point came with the development of quantum mechanics, a branch of physics that studies phenomena at the level of subatomic particles. In 1957, physicist Hugh Everett III proposed the many worlds interpretation of quantum mechanics, which to this day is one of the most influential ideas about the multiverse. According to this interpretation, each quantum decision or event creates a bifurcation, generating parallel universes in which all possibilities happen simultaneously. For example, in one universe, you choose to turn left. In another, you turn right. Both universes coexist, but invisibly to each other. Although this theory is difficult to test experimentally, it has profound implications. If true, this would mean that there are countless versions of ourselves, living different lives in parallel universes. In the field of cosmology, the idea of the multiverse gained strength with the theory of cosmic inflation, proposed by Alan Guth in the 1980s. This theory suggests that the universe underwent an incredibly rapid expansion shortly after the Big Bang. Later, eternal inflation, an extension of this idea developed by scientists such as Andre Linde, proposed that this expansion may have been uneven, creating bubbles of separate universes. Our universe would be just one of these bubbles, while other bubbles could contain cosmoses with laws of physics very different from ours. While fascinating, this idea faces a problem. How can we observe or test something that lies beyond the boundaries of our universe? However, mathematical models and simulations continue to support the possibility that these other bubbles actually exist. Another important piece of the multiverse puzzle is string theory, which proposes that all fundamental particles in the universe are formed by vibrating strings of energy. This theory requires the existence of more dimensions than the four we perceive, 3 spatial and 1 temporal. Some versions of the theory suggest that these extra dimensions may contain other complete universes, coexisting side by side with ours. String theory, although still speculative, brought new mathematical rigor to multiverse concepts. It boosted scientific imagination significantly, opening up previously unimaginable possibilities. From Greek philosophical thought to theories of modern physics, the multiverse has continued to evolve as a powerful and provocative idea. It not only reflects the human desire to understand what exists beyond the limits of the perceptible, but it also challenges our most fundamental assumptions about reality. Whether as a scientific tool, philosophical metaphor, or spiritual mystery, the multiverse is a reminder that the cosmos and our own existence may be much more vast and strange than we imagine. If once the concept of the multiverse was relegated to the realm of philosophy and science fiction, today it finds firm ground in modern science. Advances in technologies of observation, experimentation, and mathematical modeling have opened doors to explore the idea in revolutionary ways. Although we are still far from proving the existence of multiple universes, successes in areas such as cosmology, quantum mechanics, and theoretical physics have brought us closer to one of the biggest scientific questions of our time. Do we live in just one reality, or in an infinite set of worlds? When the Big Bang concept was accepted as the predominant model for the origin of our universe, it raised new questions. what existed before, and what came next. The theory of cosmic inflation, proposed by Alan Guth in the 1980s, offered a stunning solution. According to Guth, the universe underwent an almost instantaneous exponential expansion shortly after the Big Bang, allowing the formation of the cosmic structure we observe today. This expansion, however, may not have been uniform. Eternal inflation suggests that while some regions of space, like our universe, slowed down and stabilized, other parts continued to inflate, giving rise to completely independent bubbles of reality. These bubbles would form isolated universes, each with its own characteristics and physical laws. The inflation model was reinforced by real observations, such as data on the cosmic background radiation obtained by missions such as WMAP and the Planck probe. These measurements of the radiation left over from the Big Bang provided evidence that our universe underwent early inflation. While these observations don't directly prove the existence of multiple universes, they do lend credence to the idea that our universe is just one part of something much larger. While cosmology explores the multiverse on a gigantic scale, quantum mechanics does so on tiny scales in the mysterious world of subatomic particles. In 1957, Hugh Everett III presented his revolutionary many-worlds interpretation, an idea that proposed that every time a quantum interaction occurs that demands a choice, all possibilities are realized simultaneously, creating parallel universes. In practice, this means that in one universe you are reading this text, while in another you have decided to do something completely different this very second. These universes coexist, but are inaccessible to each other. Although controversial, the theory has gained ground with increasing successes in understanding quantum phenomena, such as superposition and quantum entanglement. These properties defy all or nothing logic, suggesting that reality may be much more fluid than we imagine. Advances in telescopes, space probes, and particle detectors have opened new windows to explore the cosmos and its possible hidden layers. The Hadron Collider, LHC, one of the most exciting experiments carried out to date, is conducted at the largest particle accelerator in the world, the LHC Large Hadron Collider, located in Switzerland. In the search for the Higgs boson, the so-called God particle, the LHC potentially investigates fundamental questions about the nature of matter and energy. The shocks produced by the collider can reveal particles or energies that suggest the existence of additional dimensions, or even parallel universes. The James Webb Space Telescope, JWST. More recently, the deployment of the James Webb Telescope in 2021 has brought the possibility of investigating the far reaches of the universe and studying phenomena such as early galaxies and black holes. These observations, at the visible edge of reality, could help refine hypotheses about the formation of other universes soon after the Big Bang. One of the most intriguing phenomena in modern physics, black holes, has also been identified as a possible connection with other universes. According to Einstein's theory of relativity, black holes are regions where gravity is so intense that not even light can escape. But for theoretical physicists like Stephen Hawking, black holes may not be the end-all be-all, but hypothetical portals to other realities. In his work, Hawking suggested that information sucked up by black holes is not destroyed as previously thought, but could escape to other universes. This idea challenges traditional concepts of time and space, presenting us with the possibility that black holes are in-and-out routes into the multiverse. If the existence of other universes seems impossible to observe directly, mathematicians and theoretical physicists have turned to the power of computer simulations to move forward. Sophisticated computer models have been used to test hypotheses, such as cosmic inflation and the behavior of strings in alternative universes. An example of this is the work conducted by Andre Linde and his model of inflationary universes. The equations not only suggest the mathematical feasibility of other universes, but also that these universes could be so varied and strange that they would look nothing like our cosmos. Although the multiverse is still a theoretical concept, the technologies developed to study it have real-world applications. For example, quantum experiments are shaping the development of quantum computers, which could one day revolutionize computing and solve problems that today seem insurmountable. Parallel reality concepts inspire simulation and virtual reality technologies, which can potentially recreate realistic virtual universes. Furthermore, the study of the multiverse compels us to question our position in the cosmos, influencing disciplines such as philosophy, psychology, and ethics. The advances are undeniable, but the study of the multiverse also faces significant challenges. How can we prove something that, by definition, is outside our observable reality? Many critics argue that the multiverse can never be directly tested, placing it closer to philosophy than legitimate science. However, for many scientists, this is not an obstacle, but rather an invitation to progress. Even if we never prove the existence of other universes, the search for this answer is expanding the limits of our understanding of the cosmos and ourselves. As fascinating as the concept of the multiverse may seem, it is also the subject of intense debate and controversy among scientists, philosophers, and even the general public. Its complexities, methodological difficulties, and philosophical implications raise several questions that challenge both science and our common sense, transforming what appears to be a promising future into an uncertain quest. Let's explore the main limitations, criticisms, and ethical dilemmas surrounding the study of the multiverse. One of the most common criticisms of the study of the multiverse comes from within the scientific community itself. Some argue that the idea of the multiverse cannot be considered legitimate science because there is currently no practical way to test it experimentally. In other words, how can we prove the existence of other universes if they are, by definition, beyond the reach of our direct observation? This dilemma is part of a fundamental principle of science: verifiability. Astrophysicist George Ellis, one of the most vocal critics of the multiverse within cosmology, argues that any theory that cannot be tested or falsified falls into the territory of metaphysics or philosophy. For him, relying on pure mathematics or extrapolations to validate theories such as eternal cosmic inflation or many quantum worlds can be dangerous, as it opens the door to speculations that go beyond traditional scientific rigors. On the other hand, multiverse advocates such as Brian Greene and Andre Lind counter-argue that even seemingly abstract theories can be valuable, although the other universes are not directly observable. The effects of their existence could be measured indirectly, such as variations in the cosmic microwave background or irregularities in the structure of space-time. For these scientists, the fact that mathematical models support the existence of the multiverse is already a first step towards validation. In addition to scientific challenges, the multiverse also brings disturbing implications for philosophy, especially regarding the concept of free will. If every choice we make creates a new universe, do our decisions really matter? In a way, the multiverse can make our actions trivial. If there is always another me doing the opposite of what I am doing right now, how can I value my choices? The implication can be uncomfortable, especially when designed for ethical dilemmas. In simple terms, if in another universe I became someone completely different, who am I, really? Are we all our variants, or just the combination of choices we made in this universe? These questions have no easy answers, but they highlight how the concept of the multiverse goes beyond the realms of physics and forces us to reevaluate some of the most fundamental notions about existence and identity. The multiverse is also often criticized for what scientists call its quest for elegance. Many physicists defend theories that describe the cosmos as something mathematically beautiful and orderly. But this search for theoretical harmony does not always reflect reality. For example, some versions of string theory, sometimes used as the basis for the multiverse, suggest the existence of 10 to the power of 500 different universes. This astronomical number may seem elegant from a mathematical point of view, but it is so colossal that, for many, it confuses more than it clarifies. Furthermore, critics argue that there is a fine line between using complex concepts to explain reality and simply inventing hypotheses that cannot be verified. As surprising as the discovery of the multiverse could be, it would also raise profound ethical questions. For example, if we discover that there really are infinite universes, how do we deal with the practical implications of this? Scientific question: would we invest even more resources and efforts in research aimed at parallel explorations, while urgent issues in our universe, such as climate change, inequality, or pandemics, continue to demand critical attention? This moral conflict is something that science and public policy would have to address. Existential question: how would people react emotionally to the fact that their lives are just one of infinite possibilities? For some, this can be liberating, but for others, it can trigger existential crises, or, in extreme cases, nihilism. Another risk associated with the multiverse concept is its exploration into the realm of pseudoscience. The idea of other worlds is fascinating, but without rigorous scientific explanations, it can be used to justify unwarranted beliefs or fanciful metaphysical interpretations. For example, charlatans, or even entertainment franchises can promote distorted ideas of parallel universes as absolute facts, attracting public curiosity in a sensationalist way. Self-help books, therapies that break down dimensional barriers, or even products related to reconnecting with the self in a parallel universe, often distort scientific physics to profit from what can misinform and create more confusion around the topic. While the multiverse is still deeply controversial, it also represents an evolving field and a fascinating mirror of human creativity. If, on the one hand, his ideas are not yet verifiable, on the other, they may be pointing in the right direction, towards radical transformations in our understanding of the cosmos. Like many other scientific advances throughout history, from Einstein's theory of relativity to quantum mechanics, the multiverse may seem inaccessible now, but pave the way for future progress. However, to advance, science will need to find creative and ethical ways to overcome its limitations and enable connections between the observable and the hypothetical. The concept of the multiverse is much more than simple scientific curiosity or speculative fiction. It represents a bold attempt to expand the boundaries of what we think is possible. It unites science, philosophy, culture, and spirituality into a unified narrative that challenges the boundaries of human understanding. Regardless of its veracity, the multiverse has already left its permanent mark on our collective imagination and the way we question our place in the cosmos. If there is one thing that the concept of the multiverse reveals, it is the human desire to find purpose in a vast and seemingly indifferent universe. The idea that there are other selves, living completely different lives in alternative universes, awakens paradoxical feelings in us. On the one hand, it connects us to infinite possibility. On the other, it makes us question the uniqueness of our own existence. However, perhaps the greatest impact of the multiverse is how it reflects our current concerns and dilemmas. In science, he reminds us that no matter how far we advance, there are mysteries that still challenge our ability to observe. In philosophy, he challenges notions of identity, free will, and causality. And in spirituality, he suggests that, to understand the vastness of the cosmos, we must transcend our own limits. Historically, science and philosophy have often found themselves at odds. But the multiverse could be the point where these two disciplines begin to converge. It is not only an attempt to explain physical phenomena, but also an exploration of deeply philosophical questions. What does it mean to be alive? What is reality? Is our universe just another chapter in an infinite story? At the same time, the multiverse teaches us something deeply human. The search for meaning is as important as the answers we find. This search for realities beyond the visible reminds us that we are constantly extending the frontiers of knowledge, a defining feature of the essence of science and philosophy. In popular culture, the multiverse has become one of the most fascinating and explored themes. From films like The Matrix and Doctor Strange in the Multiverse of Madness to series like Rick and Morty, the concept has captured the imagination of the masses in ways that once seemed impossible. These works are not just entertainment, they are modern reflections of the human desire to understand the choices we made, the ones we didn't make, and the lives we could have lived. Furthermore, the multiverse has inspired ethical and social discussions. It forces us to think about what it means to be unique in a theoretical universe where all possibilities already exist in some form. Do our actions carry less weight? Or is it that, precisely because we are aware of our existence here and now, our choices become even more meaningful? Perhaps the greatest legacy of the multiverse is the humility it inspires in us. He reminds us that, even with all the scientific and technological advances, we still know very little about the world around us, and even less about what may lie beyond it. We are exploring an infinite ocean with tools that have only just begun to be developed. This humility should not be a reason for discouragement, but for inspiration. As vast and strange as the cosmos is, it remains a part of us, just as we are a part of it. The act of asking and imagining what exists beyond what we see is what makes us intrinsically human. Whether the multiverse exists or not is not just a question of science, it's also a matter of perspective. He challenges us to look at the cosmos with a new sense of wonder and possibility. He reminds us that reality, whether single or multiple, is a mystery so vast that there will always be something new to explore, something new to learn, something new to dream about. Perhaps, ultimately, the multiverse is less about alternative realities and more about the way we view our own reality. He invites us to realize that, however small we may be in relation to the cosmos, our ability to imagine and question connects us to something much greater, something that, with or without multiple universes, is extraordinary in its own right. So, when we look at the stars and ask if there is another me somewhere in a universe where I made different decisions, where I lived alternative lives, we may never know the answer. But it is the simple gesture of asking that connects us to the vastness of possibilities that the multiverse represents. Because, in the end, we are all explorers, not just of worlds, but of the mystery of existence itself.